All right, so I'm looking over this review that you have for tonight, and it really only tests or checks and gives you a review of the strange sums, which you notice were absent from that first review, right? And then all the harmonic, quadratic, infinite stuff, but it doesn't do really basic stuff like find the 20th term of the arithmetic or whatever. So my advice to you, if you need to, go back and reprint maybe the first review. It's been a few days since you've looked at it, and at the very minimum, go through maybe the problems that gave you trouble. If you just breezed through it and got everything right, great. If you haven't even done it yet, definitely go back and do it. But between this thing and the other review, you probably will see a lot of that material, or at least 80–90% of the test will probably come indirectly or directly from this stuff. Now, I'm going to still probably, like I always do, pull out some random things from homework problems that maybe you felt really comfortable skipping just to see, separate the wheat from the chaff. We've talked about that, right? Good. No? Yes? All right. So I can sit up here and answer questions. I'm happy to do that for today. You're welcome to look at these problems and just work independently. If there's something that's still kind of stuck in your craw and you've got questions about stuff, I've had a couple people come in the morning or afternoon and ask questions about things, try to iron things out. You definitely got to know your formulas. If you don't know your formulas at this point, that's rough. Okay? Like, I'm willing to bet that right now I could ask a question on a simple formula that at least 2/3 of you would miss all or some part of it. Got any betters? I can't bet with you. What if I asked you this? Seems pretty basic. We'll make one up. What if I gave you okay. All right. What if I ignore this? What if I said the fifth term is 10/24 and the 15th term is 59,049. Set up what you would do, and it's geometric. I would have to tell you that in this case, because there's no telling what's going on in between there, right? It could be arithmetic, geometric, all kinds of stuff. What is the ratio? Okay. Who thinks they would know how to do this right now? So I'm getting 5. All right, guys, that's a basic formula. Literally, it's on your formula page. Now, what would you do? Somebody.
Root.
Okay, so there's going to be a root in the problem. That is true. And you want to do 15 minus 5 there? That's what I would do, because 5 minus 15 gives you a negative number. Don't really want that. So if I do 15 minus 5 here, that gives me a 10. And then if I do 15 first, where does that term have to go?
On the top.
On the top? So assuming you were able to do the division here and the square root, you feel good?
Yeah.
I said using the calculator.
So one person would have gotten it completely right. Because if that's even, what do you got to remember? Plus or minus. And if you're going, why? Because if you think about your formula, if I'm using this formula, can y'all see that? I got new pens, and sometimes they just are really light for a day or two, and then they get where you can read them. It's weird. But anyway, think about it. If I were to plug 59,049 there and 1024 here, and R there, and then place minus place here. In the process of solving, I would divide that out, right? And then I would 10th root it. And what do you have to remember? What happens when you even root a number?
It's gonna be plus n.
Well, it's going to be absolute value, right?
Oh, yeah.
But absolute value gives you plus or minus. But you don't get absolute value when it's odd, do you? So you didn't do all that math, so it's not a reminder that that happened. You just used the formula potentially. Now, if you're like, I would have done this, well, great, then maybe that'll remind you, oh, 10th root. Don't forget plus minus. It's like square rooting both sides. You always remember like r squared equals 25, square root both sides, r equals plus or minus. Same thing. Even root, gotta have a plus or minus. Now, if that had been an 11, then don't worry about the plus minus. It's not there. Y'all seeing that? Every year, I just graded my pre-cal classes, sequences and series tests, which is almost exactly like yours. There's very little difference in what they do in 10th grade and 11th grade. It's very little difference. And literally, 7 out of 10 people forgot the plus or minus. Easy. And it's their second year of doing it. You just got to remember that with ratio, if it's an even number right there when you're done. And by the way, sometimes this fraction's not bigger on the top. That's okay, right? You let that determine what goes on top and what goes on bottom. So very often, you'll get a 2/3 when you simplify all this. But yeah, I'm not going to give you a number like that. This part shouldn't be that bad, right?
It's 2 to the 10th.
2 to the 10th. So if it's going to clean up, what's a guess that is? Maybe 3 to the 10th? It's probably worth checking out. How high do you go with 3s?
3 to the 8th.
3 to the 8th is times another couple 3s. How's that work out for you?
Oh, my goodness.
Right? So you could have checked that. So even if you didn't, there's insight into that solution that you have, right? If you know your powers. Even I don't have 3 to the 10th memorized, but I have 8 and another 2, and I can quickly check that and go up, sure enough, plus or minus 3 halves. So I will make this problem, let me just double check. I don't know that I let it be a calculator problem, but let me see. I made a calculator test. Okay, so I am going to let you use a calculator if you want. Okay, and you can use any calculator you have. Does anybody here have no calculator whatsoever?
Can borrow one.
Can borrow one? Because I don't have any. Like I have an 84 in Inspire that I'm told not to loan out so that I won't get your germs. I don't care personally. I've had it, and if I get it again, I'll get it again. Whatever. I'm tired of living in fear personally. So whatever you can, but I don't have a classroom set. You know what I'm saying? So if one of you forgot or 2, I could probably help you out, but that doesn't mean you know how to use an 84 or an Inspire. You know what I mean? And I can't teach you how to use them. So everybody write it on your hand, put an alarm. I live by my alarm. I mean, I got 4 alarms that go off before 8 o'clock every morning. Or I don't remember jack. So, but anyway, do something, remind yourself to bring, all you really need is a scientific. Do y'all know how to do something like that on your calculator?
Yep.
A 10th root? Make sure that you know how to do that. It should spit out 1.5, which is 3 halves. Now, here's the thing. If it doesn't, if you don't know how to use your calculator, or you should forget a calculator, then leave it like this. Okay, just leave it like that if you can't simplify it and move on and get it done. I think that we've talked enough about how to simplify that. Now, if that was a 1024, if that was like 8196, and then another big number, and you're like, what do I even do to get started on this? I'm not going to give you problems like that. Okay? I'm pretty sure. But anyway, or if I do, and you stopped right there, I'd probably just take it right there. But make sure you know how to do like a 10th root and things like that with your calculator. But the very minimum, guys, regardless of whether you have a calculator or not, the directions say you may use your calculator to simplify your answers, but show your work. If all I see is an answer, I'm going to assume that you just guessed. And you looked at this and went, I don't know. Maybe it's 2. No, that didn't work. Maybe it's 3. Maybe it's 3 over 2. Maybe that you just guessed. I need to see like setup, answer. Y'all seeing that?
What is Martinez rule?
Oh yeah.
I heard about that.
I think we're going to call it Pozo's principle. Sounds more fancy. All right, so it's not a I like it. It's actually going to save you a little bit of brain power. It really will. In terms of all we're really doing is memorizing our way through this anyway, right? Like I know how to do them the hard way through the system, but we haven't even talked about major systems yet. So I was just really showing you more of a shortcut to introduce it. But she said she noticed this. It's pretty clever, I think. So let me just create one real quickly. If you have, say you had, man, also. All right, so say this was your quadratic. 5, let's go with, so if I gave you this, I think this works. You can look at this and you go, all right, I went down 2, up 1, up 4, up 11. No, I skipped something, didn't I? 3, 7, and okay, so let's just say I gave you this sequence. And you went, oh, look at that, -2, 1, 4, 7, 10. What am I doing? I'm going up by 3. So what would we do if we were doing this arithmetic? We need to find the formula, assuming we were asked to find the formula. Let me get rid of all this junk. Okay, so if I said, what is the formula for this sequence? So what do I do with that d value? So 2a equals 3. So 2a equals 3, a is 3/2. Great start. Then what would I do?
You get C.
Okay, and to find the c value, and this is, what would I do?
You do minus one.
So if I'm adding 3 this way, I would
Subtracting.
subtract 3, which is a -5, which would make this number what?
10.
10.
Wait. Oh.
And that's my c value, right? Everybody so far? Good? Now what we did at that point is we went and said, well, since a quadratic formula looks like that, if we take the first term, 5, and plug 1 in for the places, I get this, don't I? Which is not that big of a deal to write that down, and then to plug your A and your C in. And this is what we did, and we solved for B, right? Well, she noticed this. She said, Mr. Hurry, actually, she just noticed something, but this is the explanation of why it works. She said, why can't you just say A plus B equals -5? But the reason why that works is your C value is also your what? Your T0. And if your N is 1, this is a T1. So what is A plus B equal to? T1 minus T0, right? Algebraically. Well, what is this number? T1 minus T0. So what, does that make sense?
Yeah.
So what that enables you to do in the whole scheme of things, yeah, you don't even have to think about this equation anymore, right here. You can just go, whatever that number right there is, that's your A plus B. And then all you got to do is plug your A in and solve for B. And then you got your ABC. So really, now my keys don't reflect that because my keys were pre-Pozo principle. Okay? So, but yeah, if you want to do that, great. This value right there, because it's the T1 minus the T0, that is equal to the A plus B. And a lot of times kids will tell me stuff and I'm like, no, that's good, but I don't really feel like it helps. I kind of really like that. If you're really memorizing, 3, bam, there's your A. Go back one step, bam, there's your C. That's A plus B, bam, there's your B. It's like I can get there in 20 seconds now. You know, Tn equals 3/2 n squared minus 13/2 n plus 10. Pretty nice. Now, if you learn it this way, you will have literally no knowledge of the math that's going on, most likely. But the math that's going on is we actually cover a lot of that in pre-cal with larger systems. Did anybody notice on your review sheet from that we did the other day, there was a problem that wasn't arithmetic? It's maybe number 3 on the page, and it wasn't geometric, but there was a pattern to it. Do y'all remember it? Like this, it's right. I'll pull it up, and I'll just mention this. It's possible that something like this shows up on a test, but let's see, where is it? You know what page that review's on?
63.
Okay, I'm heading in the right direction. Okay, so right here. You saw this problem? If I saw this problem, I go, well, it's not arithmetic, it's not geometric, maybe it's quadratic. Looks kind of like it might be quadratic, right? You might go, oh, it's harmonic, maybe. But harmonic, man, that'd be a pretty crappy common numerator to find, wouldn't it? Whenever I'm feeling myself, that's going to be a really crappy common numerator, then it's probably not harmonic. Because it's just too hard. I wouldn't have given you something that nasty that you had to have a 31 as prime, a 5, a 3, and a 2 in. That's a really ugly number. You can do it, but you'll see that the denominators are not arithmetic. So then I thought, well, maybe it's quadratic. So 1, 4, 9, 16. Well, that's not arithmetic either, is it? But watch this. What are the differences between those? 3, 5, 7. Oh. So the second set of differences are arithmetic. Well, if one set of differences is arithmetic, we know the graph was quadratic, right? If the second set is arithmetic, then instead of having this as your formula, you would have this. It'd be a cubic equation. So this formula right here, the 1, 2, 6, 15, 31, actually comes from that kind of equation. And in pre-cal, we pull out the inspires and we actually set these systems up. But your calculator has this great program. It's a way to basically solve a giant matrix or simplify it into a certain form called reduced row echelon form. And when you do that, it just spits out the A, B, C, D, and you just plug them in. So we'll eventually really talk about the math of this, but right now, we're going to skip through the math of these weird formulas and just kind of use some tricks. Because in Algebra 2, sadly, schools don't really stick to the rules. It's kind of like when I was a kid, my brother was a year older than me, actually less than a year older than me, so we're pretty close in age. So, you know, you fight when you're little, but we had a no punch in the face rule. It was just a rule we had, kind of like to keep it, you know, safe. Plus, my dad always said whoever won had to fight him, so we were like, well, you can't make it obvious who won. So, you know, we would wrestle or fight or whatever. Well, anyway, there's a reason I'm telling this story. Hey, mine's blanking. What were we just talking about?
Algebraic things.
You said they never really
People
followed the
breaking the
rules.
rules.
Yes, thank you. So, when you go to these tournaments, they say it's Algebra 2, but I've seen Euclidean geometry once, and I learned Euclidean geometry in graduate school. I've seen problems on lattice points and things like that that I literally learned in second level Euclidean graduate school course. They threw it on an Algebra 2 question because they're jerks. So they don't really follow the rules, or maybe because if there is a way to do it in Algebra 2, never mind that it might take you an hour, but if you knew Euclidean geometry, it might take you 30 seconds. Never mind that, you could have done it. So we're going to put it on there. So this is one of those things, those quadratic equations, that does show up because they're like, it's a quadratic, right? It's parabolas. Everybody talks about parabolas. But yeah, it would take you a good amount of time to solve a system or a cubic. We study cubic equations, polynomials. That take a lot of time to solve that. But tricks sometimes are the way to go. But next year, if you're in here, we'll talk more about the math of how those work. Because you can find the equation on these. But this one you see a pattern too. Plus the pattern was kind of nice. What are you adding each time? 1, 4, 9, 16. What are you adding? Perfect squares, right? So if I added 16 here, the next one's 25, 36, 49. So I made it a little bit easier in that case, but it certainly is not arithmetic or geometric, so it doesn't have a common ratio, it doesn't have a common difference, anything like that. And what else? Is this the end of the book?
Yep.
Yes, it is. It makes sense, yeah.
Usually number 11 on that one.
Hours, please.
This one?
No, it's on a different one. It's like, how many multiples of 4 are there between 50 and 950?
50 and 950? Okay, so tell me, the people who have issues with this in the past make a bunch of common errors. If I want multiples of 4 between 50 and 950, now the first mistake that people can make is assuming that 50 is a multiple of 4. It is not. I see people all the time, they go, all right, multiples of 4. So they go 50, 54, 58, they start writing that out. But those aren't multiples of 4, right? The second type thing people mistake is, even if it was, like, what if I said multiples of 4 between 52 and 948? If I say multiples of 4 between two things, I do not include those two things. Are y'all with me on that? So really, if I said in between here, even if they were, I would start with 56 and go through 944, and I would be counting those. Now, how do I include them? What do I say? Inclusive. So those are a couple things that happen. Another thing people make mistake with is they go, oh, if it's a multiple of 4, then it must be a geometric sequence, because that's when I multiply. But wait, if I started writing out the multiples between 50 and 950, the first multiple I get, because I'm going 48, is what, 52, 56, 60, and 950. I know 900 is a multiple of 4, because every 100 is. So if it's 900, I know 940 is. So I know 944, 948. I can only go through 948. So the key is to find those two values, but then you can see if it's a multiple, it's not geometric at all. What is it? It's arithmetic. So if I want to know how many are there, what do I need to find?
How many are there?
What variable stands for how many there are? It'd be the n of that term, because the place of that term tells me how many terms I have. So I would say, well, I got a formula for that. T1, Tn equals T1 plus n minus 1 times d. So at 948, if 948 is the term, it's in the nth place. If 52 is the first term, it's in the first place. Put a plus, and the common difference is clearly a 4. I'm going to subtract the 52 and get an 896. You can distribute the 4 if you want. I'm going to divide by the 4 and get a 224, and I'm going to add a 1 and get a 225. So that's what I would do. But there's a lot of ways you can go wrong with that. And even if I say between and inclusive, do I count 950? No, because it's not a multiple of 4. So be careful about that kind of thing. Now, did we go over that problem where I said, like, how many terms between, like, let's just say, how many terms between and inclusive, between 1 and 100, are not multiples of 3 or multiples of 5? No, I'm sorry, are multiples of 3 or multiples of 5. How many terms, number of terms that are multiples of 3 and multiples of 5? Have we talked about a problem like this?
We rushed through.
We did kind of move through it quickly. Let's look at it again. So I'm going to write out just enough for you to see what's going on here, and you really can kind of memorize this. But like if you think about all the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm going to go through 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, dot, 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 I'm gonna go 99, comma, 100. Now, if I wanna count the numbers that are multiples of 3, what would I be counting?
3.
I'd be counting 3, 6, 9, 12, 15, 18, 21, 24, all the way through 99, wouldn't I? Multiples of 3? So how would I do that? How would I count that? I need to find what variable? For how many terms? The n. The n of what? Of the 99? Is this arithmetic or geometric? Arithmetic? Okay? So if I wanted to count those up, I would say, all right, the number of terms, I could say find the sum of them also, but I'm just counting the number of them on this one. I could say, so if the question was the number of terms, I would say, well, using this formula, if I know that last term is 99 and the first term is a 3 in the ones that I'm counting, right? Then right here, I could go common difference is 3, and I could solve this, couldn't I? And I end up getting, when all's said and done, 33 terms. Are y'all with me? Now, then I would say, well, now I need to count up what? Multiples of 5. Well, the problem with this is, the multiples of 5 are 5, 10, but what just happened? 15, 20, 25. Oh, by the way, if I kept going, 24, 27, 30, you can see 30. And I'm going to go through 100 on these. But on this, if I'm counting these, I'm going to do it the same way, right? Tn, T1, n minus 1 times d. But this time, I'm going to go through 100, starting at 5. Common difference is 5. And when all's said and done, I get n equals 20. But what did I do accidentally?
You counted multiples of 15.
I counted the multiples of 15, which is 3 times 5, twice. So if I just do this, if I go, hey, there's 33 plus 20 terms, 53 of these are multiples of 2 and multiples of 3, multiples of 5, I overcounted, didn't I? Because I counted those twice, the 15, the 30, the 45, the 60. So how do I rectify that? I am going to find out how many multiples of 15 there are. Sorry. How many multiples of 15 using the same thing. So what's the last multiple of 15? I didn't actually write it down there, but that's not too bad to find, right? 90. So the last term's 90, the first term's 15, the multiple is 15, and I end up getting n equals 6. So I would end up having to do this. Not 53, but 47 actual terms.
Why would you not put like plug 5 in? Because
What do you mean plug 5 in where?
like, why is it 15? Because it's the product of 3 and 5?
Yes, because look, double counted on 15. Double counted on 30. I didn't double count on 5, 10, or whatever, just the multiples of 15 that I double counted. Are y'all seeing that? Now, a lot of times they say, what's the sum of the terms that are multiples? Well, in that case, what would I have to do? Find the sum of them. But at least you did the work already, right? What's the sum of these that are multiples of 3? Well, there's 33 of them. The first one is a 3. The last one is a 99. Here, there's 20 multiples of 5. First one is a 5. Last one's 100. And here, there's 6 multiples of 15. First one's a 15, first one's a 90. So if I had said find the sum, you would just add these two together and then what? Subtract them. But I might say find the sum of them. I might say how many of them, just read. But that's a math team question. Vestavia's made it even worse before. They had a number 25 once. It said find the number of terms that are multiples of 3. Find the sum of them that are either multiples of 3, multiples of 5, or multiples of 7. So you know what you had to do? You had to add the multiples of 3, 5, and 7. You had to go back and subtract the multiples of 3 and 5, 5 and 7, and 3 and 7. And then you had to go back and add the multiples of 3, 5, 7. It was awful. But there's that pattern where it's like, but anyway, that's not something I would ask. I have asked that in the past, but it didn't go well. So it's been many, many years, probably 20 years since I put it on there. I've even put it as a bonus for a while, and I'm like, nobody's getting this. I'm happy if you understand this, because this is a more common kind of problem that show up. And anyway, y'all seeing that?
Yep.
Anything else, guys? Anything? Strange sums? We still got plenty of time. Strange sums, quadratics, harmonics. Anything you want to think about? Do what? Anyone?
Just some like examples, maybe, of just different problems.
There's just so many.
Exactly.
So is there anything that's been giving you trouble? Anyone?
I got a question.
What you got?
Could you just work one of the sequences where it's like the last one is like T to a number? Just because it's confused sometimes.
Can you give me an example?
Like number 7,
On what page?
the first review, so 63.
Okay, if you see something like that, the first thing, make sure you read the directions. I have a lot of people that I write that, and they go, oh, I need to find T401, which in this case is what I asked you to find, because I said, find that term. But I also, a lot of times, I'll say this, and I'll say, what is the sum of these terms? And in that case, don't find T401. I mean, you might need to find the sum. That depends on what kind of problem it is. But be careful and make sure you're actually doing the right thing. Now, if I want to find, I didn't say that here, so I want to find the term. Well, what kind of sequence is it? You got to determine that first. What's going on here? I'm subtracting 6 each time. Now, you got to have that checklist, right? So if you determine you're subtracting 6, that means the difference is -6. Then I pull out my arithmetic formula. Now, how do I use that arithmetic formula? I'm looking for T401. So if I'm looking for the term, what do I do with the 401? The place of that term goes where? Right there. And then you fill in what else you know, right? The first term is 21. The common difference you found was a -6. Make sure you don't write it as just -6. It looks like you're subtracting. Go times, parentheses, -6. And then if that's the first term, right? Now I use the first term because why not, right? 21, but I could have used 9. If I use 9, then I'm not calling it T1. 9 would be what? T3, and put a 3 there. But I don't know why you would do that. I always use the first term if I can, and then put a 1 in. So what would I get? 21 plus 400 times a -6. So -2400 plus a 21. So what? -2379. But I would do that whether it was, if it's arithmetic, if it's geometric, I just pull out my geometric formula. But you have to decide what to do first. I see people all the time using the wrong formula on the test. And their thinking is wrong, and they're putting stuff with it. They look at this and they go, oh, 15 over 21 is 5/7. The ratio is 5/7. Well, if it had a ratio of 5/7, great, but 9 over 15 is not 5/7, so it does not. It could have if I changed the problem, but I didn't. So you got to make sure you pick the right equation, right? And then go from there. Yeah?
Can we do like a geometric thing, like insert 5?
Sure. 10 on this thing? Okay, so number 10, insert 5 geometric means. So what does that mean when I say to do that? That means that there are what? 5 terms in the middle between these two where this becomes a geometric sequence, right? Well, if that's the case, then what has to occur here? There has to be a ratio. I don't know that ratio. You might be able to eyeball that and see it. I don't know what it is. I'm guessing this looks very like a bunch of 3s. This looks like a bunch of 2s. The only way I can go from a bunch of 2s to a bunch of 3s is multiply by 3 and divide by 2. So good common sense makes me think that it might be a 3/2. Might be a -3/2. Might be both. Let's see if we can find that out. So how do I find ratio? 1, 2, 3, 4, 5, 6. Seventh term. 7th place minus 1st place. 729 over 64. So this is the 6th root of that. Who knows what that number happens to be?
3 to the 6.
3 to 6, 2 to the 6. And what do I do with this 6?
Plus and minus.
Plus and minus. So I get plus or minus 3 halves. Now what does that mean? That means there are really 2 sequences out here, or 2 sets of means. There's one that's going to go with what?
Plus.
With a positive 3 halves. So what's that times the 3 halves? Well, the 2 would cancel, giving me a 32, so 96. What's 96 times the 3 halves? 48 times 3 is 144. Are you getting the picture? Etc., etc. But what if the ratio is negative? Then this becomes a negative 96, but then back to a positive 144.
So
The next term is going to be positive across the top, but this is going to keep alternating negative, positive, negative.
That's how you would show your answer with
You
2.
put the plus.
I would probably write plus or minus 96, positive 144. Plus or minus blah, positive. Blah. But you could write it twice. It's up to you.
Can you do one of the Pascal triangles? I kind of forgot that.
Okay, so if you're finding like a term in an expansion, that's what you're saying?
Yeah, it's 24A.
It's what?
24A or 24B.
Oh. So if I said, what are the sum of the terms in the 10th row? Okay, I really don't want you to go to the 10th row. Please don't do that. So let's notice a pattern. We've already talked about this earlier in the year. If I sum the first row, what do I get?
1, 2, 0.
If I sum the second row, third row, fourth row, fifth row. So the 5th row is 16. Doesn't that mean that the 5th row is 2 to the 4th? The 4th row is 8. The 4th row is 2 cubed. So if I ask you for the 10th row, based on that pattern, it should be what? 2 to the 9th or 512. Now here's what gets messed up. The 10th row, okay, like the 5th row has the 4 in it, the 10th row has a 9 in it, 1 9. The way mathematicians talk about this, they call this the 9 row. The 9 row has a 9. That's why it's called the 9 row. It's called the 9 row because you've expanded a plus b to the 9. But is it actually the what row? If you're counting, it's the 10. So over here it says the 6th row. Well, the 6th row is the one that starts with a 6 and ends with a 6. That came from going a plus b to the 6th. Right? Expanding it. Well, the coefficients, 1 plus 1 is 2, 2 to the 6th. Because the 6th row is really the what? The 7th one. So 6th row, 2 to the 6th. 7th row, increase it by 1 and then raise it to that power.
Can you do number 9 on page 82?
Is it this?
Yep.
So 83?
Page.
Weird. Okay, whatever. We'll go with that. So, what do you see? I look at this and I go, I don't know, kind of looks like it might be geometric. I'm multiplying by 2/5. Oh, but wait. If I was multiplying by 2/5, what should the next term be? 8 over 125. It's not. So actually, it wasn't geometric, was it? What is it?
Harmonic.
It's a weird sound.
I mean, if you tried harmonic, let's just say you tried it.
Oh, wait, you pull up over here.
The first thing I would talk to you about harmonics is, we don't know how to find the sum of a harmonic. We only know how to find the next few terms using a pattern. So I'm never going to ask you to find the sum of one of those. And this says find the sum. So you can rule that out. It's not going to be the, and same thing with quadratics. I don't find the sum of quadratics. There is a way to do that, but we haven't learned it. Okay? So I look at this and I see arithmetic over geometric. What is that? That's a strange sum. And how did I do the arithmetic over geometric problems?
Pull out.
I named it S.
And then make that negative
One fifth.
And then I multiply the top and the bottom by a negative 1 over 5. It's always going to be a negative 1 over something, and it's whatever the bottom is getting multiplied by. So a negative 1 over 5. So what's S times a negative 1 over 5? Negative 1 over 5. That's right, that. People all the time try to do these problems without these equations. What is that times a negative 1 over 5?
Negative 2.
Negative 2 over 25. And I'm going to slide it over. What's that times a negative 1 over 5? Negative 4 over 125. Etc., right? And if these all line up, when I start adding, what's 1s minus a fifth s? What's 2 fifths and nothing? And then what I get on the remaining, I'm just going to go ahead and write this other one. I get 2 over 25. I get 2 over 125. I get 2 over 625. And you are always guaranteed that these are what? Infinite geometric. Now on this one, it just happens that that actually works with it, doesn't it? Now I can still do this with an infinite geometric, and when I'm done, add a 2 fifths. Because normally this doesn't sync well with this one. It just doesn't work with it. But this time it did, so if you wanted to, you could include it. Just for the sake of consistency, I'm going to pretend I didn't notice that. And I'm going to go 2 25ths over 1 minus 1 fifth. And when I'm done, I got to finish out this equation. What's 1 minus 1 fifth?
4 fifths.
So to divide by 4 fifths, what do I do? Multiply by 5 fourths. That cancels and leaves me 2 over 20 or 1/10. What's 1/10 plus 2 fifths? 3 a half. Because 4/10 plus 1/10 is a half. Again, bring this down. And if 4 fifths of S is a half, what's S? I'm going to multiply by 5 fourths on both sides. And I get 5/8 as my sum.
Thank you.
You do 11.
Well,
What was it?
the number you subtract, you subtract 4 25ths minus 2 25ths. Will the number you subtract by always be the numerator of the one before over the denominator?
Well, the numbers I subtract,
Because, yeah, your negative.
I'm always going 4 minus 2, 6 minus 4. Is that what you're
Yeah.
saying?
Well,
You can come up to your point.
Yeah.
That helps.
because it's always 4, always goes there, and then you just bring the denominator down.
Yeah, you were trying to just make it quick.
Okay,
Yeah,
because I noticed that, and that's what I've been doing.
sure. Yeah, like if you wanted to just take that 2, 4, 6, 8, slide it over and go 2, 4, 6, 8, and then copy the same denominator, you're not really, that's totally a quick way to do it. Does that make sense what she's doing? That's how it ends up playing out. That's not, and you could actually save yourself the trouble of thinking on that if you're just looking to knock it out quickly. But make sure you remember what you did, because you got to know this value, right? So if you want to do that real quickly just to kind of get something down on your paper, you can. But make sure you remember the process, because you still have to know what that multiple is so that I can add these two together and get that 4 fifths. Because if I don't actually think about it, now I just did this, if I just went, okay, 2, 4, 6, 8, 25, 125, 625, yada, 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 change the signs. I'm going to get that, but I'm not going to know what this is. So you do have to think, what did I really do? I multiplied that by a negative 1/5. I've got to know what this is to set it equal to that. But as far as writing it out, yeah, that's a quick way to think about it. Anything, you said what?
Number 11. Just write one.
So it says find the formula, right? So for a formula, I've got to figure out what kind of an equation it is. Could be arithmetic, could be geometric, could be all kinds of weird things. It's probably not a strange sum. Why? Because I haven't really asked you for formulas for a strange sum, have I? I've just asked you to sum them. So I'm guessing it's something that I've asked you to find the term of. Let's see. Well, 7, it's not geometric. Arithmetic, plus 5, oh wait, plus 6, plus 7, plus 8. What does that mean? It's quadratic. So if it's quadratic, I go, well, that was a difference of the differences is 1. So what does that quickly tell me? So A is a half. I can find the term prior to that by what? So that would have been a -2. So what does that tell me? C is -2. And if you want to pull out Pozo's rule, 4 equals A plus B. B is 7/2. The formula is 1/2 n squared. It's really a nice rule. 7/2 n minus 2. Correct me, Pozo's principle. Right? Really makes this kind of an easy problem. These used to be the hard problems of the test 20 years ago. Because you had to go through all that system of equations. Now it's like, you hiccup and you're done. I mean, it's just not much to do if you know the steps. But you gotta identify what it is. Capiche? Alright. Now, hey guys, if you're still one of the ones that's struggling on these, I got Thursday, Friday, and Monday to quiz you. Alright, only takes 3 minutes. So I would be ready. I actually kind of wanted to today, but I just realized I forgot to make copies. So I don't have enough copies. But I shall tomorrow. Not tomorrow, Friday. No, Thursday, sorry. So if you haven't really prepared, if you're still getting 10s and 12s, get out some flashcards tomorrow night. Spend a few minutes making sure you really know them. Right? All right. Yeah.
Are you sure that